10 million people have Parkinson's disease. Parkinson's is a disease that eventually takes away a patient's ability to walk and talk. Unfortunately, at the moment, this disease does not have a cure. Once a person gets it, it's something that they're going to have to deal with for the foreseeable future. But we can make this disease easier to deal with. Over the years, numerous studies have found that early detection improves treatment and creates a better outcome for the patient. Yet, doctors are still struggling to perfect early detection. Diagnoses often miss symptoms, and there's no one universal test to detect the disease. Oftentimes, doctors only notice it when it's too late. But the answer is right in front of us, and it lies in a technology called quantum machine learning. With quantum machine learning, we can run complex classification problems to diagnose whether or not the patient has the disease. Let's break down how it works. Machine learning can be broken up into 3 core categories: reinforcement learning, unsupervised learning, and supervised learning. In this video, we're going to be focusing on supervised learning. Supervised learning is really simple. We feed the computer unlabeled data so it learns the difference between 2 objects. Then, we give it an unknown data point and it will use its past training to predict which category it falls into. For example, we feed the computer 100 data points from people with Parkinson's and without. The computer analyzes the features of the data, like tone, pitch, and frequency. Then we give it a data point from an unlabeled patient and it's able to predict which category they fall into based upon their previous training. A lot of times, it's really easy to predict between these 2 categories, but when features start to overlap, that's when it gets more complicated. Picture 2 data points stacked on top of each other. The computer needs to draw one line to separate the 2, but it's impossible. It's 2D and they're right on top of each other. But a certain supervised learning algorithm can solve it. These are called support vector machines. They have the unique capability to separate data in the nth dimension, or 3D. They project the data points into a higher dimension until it's possible to slide a sheet or a plane in between them. This makes them a very popular and useful algorithm, but the problem arises with bigger data sets. Many classical computers don't have the computational power to project such big data sets into higher dimensions. And even if they did, they don't have the time to do so. It would take years or decades. That's where quantum computers come in. Due to the power of quantum properties like entanglement and superposition, quantum computers have the computational powers to solve these problems faster. Quantum machine learning is a field that allows scientists to take a classical machine learning algorithm and transform it into a quantum circuit so it can be run efficiently on a quantum computer. When trying it out myself, I imported a Parkinson's dataset and built a quantum circuit to predict whether or not 9 unlabeled patients had the disease, and the results were great. The algorithm was able to diagnose the patient with a 75% accuracy rate. With more stable hardware and a larger dataset, that accuracy rate is only going to go up. Algorithms like this one can help doctors begin treatment earlier and save lives. And this is only a sliver of what quantum machine learning can do. It can classify cancer cells, detect new drugs, further space exploration, and so many more things that we're just waiting to see. The solution to so many problems is right in front of us. The solution is quantum machine learning. And the best part is that quantum machine learning can happen now. Many quantum computers are already advanced enough to handle these type of computations. As quantum technology advances in the coming decades, it'll only get better. Thank you for watching. I'm Anisha Musti. Be sure to check out my LinkedIn, Medium, Twitter, and all that stuff down in the description box below. And you can also check out my other videos where I talk about quantum computing and quantum machine learning. Hope to see you next time.